Step one for us is going to be understanding what megastructures is going to mean for the remainder of the semester. So this is week 8, right? So it's technically midterm week. And I was thinking about doing 2 projects for our final project, and I've decided not to. What I'm going to do instead of 2 separate projects is I'm going to thoroughly explore using Grasshopper for what I truly believe is one of its strongest applications, and that's megastructures. So in doing that, we're not just going to be building your typical skyscraper like you see all over New York and Chicago and LA. It's better than that. We can use it to visualize systems that are beyond what we currently can construct in the field of architecture. And we can think about it from a societal perspective rather than just a pragmatic perspective, right? Societal meaning these buildings can be much more than just a building. They can be ecological, they can be sociological, they can be economical, they can be every sort of study and application to the human condition that you want it to be. So, in saying that, one of the things that I wanted to point you to here is this website. It's an architecture magazine, and they are, I'd say, they're really kind of far out there. Not terribly far out there like Terraforma and stuff like that and Earthship, but they tend to really study people who are at the farthest reaches of design. And a lot of it has really well-grounded applications in algorithmic design, right? Computational modeling. So this is a really great resource for us. One of the things that I wanted to point you to with Evolo is that they actually put out a skyscraper. They have a hugely successful skyscraper competition that they run annually. And the renderings and designs that come out of this competition are stellar. So you absolutely should be checking in on this caliber of resource as you're approaching the rest of your studies. So let's take a look at a few examples. These are the 2017 winners here. That's not number 1. Number 1 was this one, I believe. But what I want to point to is every single one of these projects came from the same design prompt, and they have tremendously different solutions to what that design prompt is. And the design prompts, in many cases, are pretty open-ended, so you can kind of go a lot of different places with it. That one is very clearly algorithmic in a way, right? You just do the same thing over again, and it processes, and it builds the whole tower. Some of them are not so clearly algorithmic, like this one, but you can see a lot of elements in the algorithm sort of in the facade system, but this one's a little bit more graphic than it was actually modeled. This one, it looks like they might have modeled the surface a little bit and then just photoshopped in some of the other stuff to communicate the idea. That's okay, though. That one's kind of cool. This one's kind of similar to some of the other structures, but you can see a lot of elements of, either layering systems or structural systems that could be algorithmic in essence. This one is very clearly algorithmic, but it also looks like it might be more of a graphic exercise. And this one as well. So these aren't the best examples. I just wanted to show you the most recent ones. What I do want to show you are some other ones that relate a lot to what we're going to start to address. And this one is not far from your reach at this time, is it? Not at all, right? Because it's a series. I mean, if you were to begin to conceptualize how to design this thing in Grasshopper, you would probably start with that plate in the middle, right? And you know that you can subdivide that down into squares, and then you can reduce those squares and cut holes in it. And then you can take those holes and you can extrude them into towers, and then you can move them up and down, right? So it's really quite simple to abstract ideas from the concept, turn them into an algorithm, and then it becomes architecture very easily. where we're going to be taking the next couple weeks, and we're going to start with something very similar. Like think this, but like way boiled down. Super, super schematic, just boxes, understanding stacking floors and stuff like that. But we're eventually going to get to a point where we're developing facade systems and skin systems. And in some cases, they might wind up being really intense. I'm not quite sure how much I'm going to let you off the leash on that, but think way outside of the box of what defines space and architecture. Okay, but also we can think a little bit more about systems that are not quite so much architecture, but also integrated technologies, right? So this, I don't know, I didn't read through all the prompts for this, but it looks like a hub for drones, something like that. So anyway, it kind of cutesy, but whatever. But this is kind of the level of elegance that I'm hoping we can achieve. If you think about this from a design perspective and an algorithmic perspective, it's not that hard to do. It's an elegant, simple design that would benefit greatly from using Grasshopper in order to generate it, right? So this is our goal, not so much that. Does that make sense? So don't get intimidated by these things that you see. We want elegance, simplicity, and efficiency. And we can start to really take that elegance and simplicity and develop really intense forms with it, but we're not going to create like all of those biomimicry forms and stuff like that. We're going to really focus on the quality and massing of the architecture rather than the algorithm of nature, which is kind of overplayed and not as useful or applicable to many other things. So something like this is within the realm of possibility, or even something like this. Even though, well, I say within the realm of possibility, but I mean in the realm of possibility for us, but not really possible in real life. But anyway, the way that you're going to have to think about this is to think of really, really abstract ideas, boil them down into algorithms, and then apply them to the design process. And that's the key. I want you to walk out of this class knowing how to conceptualize using variables, if that makes any sense. It should start making, I mean, by now that should make some sense to you guys. Okay? So what questions do you have?
Are you going to give us the prompt?
Right now, no. I'll give you a prompt. We're going to start off with some simple like studies and stuff, and then I'll probably introduce the prompt in like 2 weeks. Yes?
So this is like the bridge kind of where we're going to like create our own? Or we're going to like do something that you follow along to?
I'll probably design the prompt in such a way that you have certain types of algorithmic systems that you're going to utilize. But in terms of what you do with that and what the design becomes, that is going to be pretty wide open. Okay? Did that answer your question?
Kind of.
Okay, yeah. Like the bridge one, you guys all had, well, not really. I mean, bridges are bridges, right? And most of you had suspension bridges, so they were very similar. But each one of you had one thing that was like a little bit different that you each had to do. And I would say that degree of deviation from each other's projects and approaches is probably what I'm going to try to curate for this experience as well. Does that answer it a little better? Okay. Any other questions? Okay, so I'll just introduce that one in the next video. Hang on.